Dear students, today we will discuss about the multiplexing and demultiplexing in the communication. So what is the multiplexing and demultiplexing? What is the role of in communication field? So multiplexing is the set of technique that allows the simultaneous transmission of multiple signals across a signal data link. Multiplexing is done using a device called multiplexer mux that combine n input lines to generate one output lines or many to one or many signal converted into the single signals. At the receiving end, a device called demultiplexing, demux, is used that separates signal into its component signals, one input and several outputs, or one into many, one signal converted into many signal in the demultiplexing process. So in multiplexing, there are different n input lines, and these input lines converted with the help of multiplexer into the n channels and one link, and again at the demultiplexer, the one link or n channels convert into the n output lines. So this is the processing and multiplexing. And what is the advantage of multiplexing technique? So more than one signal can be sent medium or a link. Effective use of the bandwidth of the medium in the multiplexing system. So they are multiplexing versus no multiplexing. So here in no multiplexing and multiplexing diagram. So in no multiplexing diagram, there is the different inputs connected to the different output devices by the one by one. What in multiplexing technique, there are many inputs or many input signal or many input data converted into the one path or one channel of the four channels into the, and next in demultiplexing, this one path or one channel converted again to the different and outputs. So this is the multiplexing versus no multiplexing difference. Types of multiplexing. So there are many types of multiplexing. Multiplexing basically converted or divided in three types. First one is the frequency division multiplexing, that is the analog technique. Second is the wavelength division multiplexing, WDM, that is the also analog technique. And third one is the time division multiplexing, TDM, that is the digital multiplexing technique. The time division or TDM multiplexing also divided in two parts. One is the synchronous TDM and second is the asynchronous TDM. So these are the different types of multiplexing in the form of analog and digitals. So what is the frequency division multiplexing, FDM? It is the part of analog technique. It is a analog technique. Signals of different frequencies are combined into composite signal and is transmitted on the single links. Bandwidth of a link should be greater than the combined bandwidth of the various channels, and each signals is having different frequencies in FDM multiplexing systems. So channels are separated by the strips of unused bandwidth called guard band or to prevent overlapping. So the function of the guard band to prevent the overlapping. So that is the FDM frequency division multiplexing system. Application of FDM. So there are application of FDM. So first is the FDM is used for frequency modulation and amplitude modulation radio broadcasting. Second one, AM frequency range is the 530 to 1700 kilohertz, and range of the frequency in frequency modulation is the 88 to 108 megahertz. So this is the frequency range of the FM frequency system. FDM is used in television broadcasting, and first generation cellular telephone also use this FDM techniques. FDM in time domain multiplexers. So there are different input signals which have the different frequency F1, F2, and F3, and these are multiplex, and summing of these different signals into summing network, and after this multiplexing, these different input signals convert into the one signal, that is the FDM in time domain form. And in multiplexings, there are used different modulation technique which have the different signals of different frequency F1, F2, F3, so on. And the output of this multiplexer is the output FDM signal that is sending bandwidth to the on the channels. Next one is the demultiplexing technique and time domain system. So here is the FDM input signals, and these FDM input signals divided into different inputs, and the output of different filters have the different signals that have the different frequency, and these different frequency signals, which is more than one, convert into the output signal with the help of demultiplexing technique. And so the in this FDM signals convert into the different analog signals with the help of demultiplexing technique in time domain form. So in demultiplexing, we use the different filters, and after the filtration of different input signals, and we convert in different these signals into the output signals with the help of demodulation technique. This is the opposite process of the modulation techniques, that is in the demodulation technique, and the output of here the different output input output different frequency signals. So these are the different outputs of demultiplexer systems. Next one is the wave division multiplexing, WDM. So WDM is an analog multiplexing technique. Working is same as FDM. In WDM, different signals are optical or light signals that are transmitted through optical fiber. Various light waves from different sources are combined to form a composite, composite signals that is transmitted across the channel to the receiver. On the receiver side, this composite signals is broken into different light waves by the multiplexing technique. So this combining and the splitting of light wave is done by using a prism. Prism bend beam of light based on the angle of incident and the frequency of wave light. So this splitting of light wave is done by the prism that can be see in this diagram. There are the different input light signal which have the different wavelength, lambda 1, lambda 2, lambda 3. And after multiplexer or multiplexing technique, the different light signal transmitted on a single fiber optic cable, and again these signal demultiplexed by the demultiplexing technique, and output of demultiplexer is the different light signal which have the different wavelengths. Next one is the time division multiplexing, TDM multiplexing. So it is the digital multiplexing technique. Channel link is not divided on the basis of frequency, but on the basis of time. Total time available in the channel is divided between several users. Each user is allotted a particular time interval called time slot or slice. In TDM, the data rate capacity of the transmission medium should be greater than the data rate required for sending or receiving device. This is the TDM, time division multiplexing systems. Types of TDM, so they are two types. First one is synchronous TDM and second one is asynchronous TDM. In synchronous TDM, each device is given same time slot to transmit the data over the link, whether the device has any data to transmit or not. In TDM, each device places its data onto the link. When its time slot arrives, each device is given the position of line turns by turn. And if any device does not have data to send them, its time slot remains empty. Time slots are organized into frames, and each frame consists of one or more time slots in TDM synchronous systems. If there are n sending devices, there will be n slots in frames. So in this diagram, that is show the synchronous TDM system. Numbers of inputs here, 5 number of slots in each frame, 5. So that is the synchronous TDM systems. What is the multiplexing process in synchronous TDM system? In STDM, every device is given opportunity to transmit a specific amount of data into the link. Each device gets its turns in fixed order and for fixed amount of time interleaving. Interleaving is done by character 1 byte. Each frame consists of 4 slots as there are 4 input devices, and slot of some device go empty if they do not have any data to send. So this is the TDM multiplexing system of synchronous TDM multiplexing systems. And this diagram also show the demultiplexing system of the STDM. What is the disadvantage of STDM? In STDM, the channel capacity cannot be fully utilized. Some of the slots go empty in certain frames. So this is the disadvantage of STDM system. This figure shows the framing of bits, synchronization pattern of the framing bits. Next one is the asynchronous TDM, ATDM. There are different number of inputs, that is 5, and number of slots in each frame, 3. So this shows the asynchronous TDM systems. In asynchronous TDM, also known as statistical time division multiplexing, in this time slots are not fixed or slots are flexible. Total speed of the input line can be greater than the capacity of the path. In ASTDM, we have n inputs lines and m slots. So m less than n, because here n is the input lines and m is the slots. So m less than n here. Slots are not predefined, rather slots are allocated to any of the device that have data to send. This diagram shows the frame and address, and only 3 lines sending data here with the help of multiplexing technique systems, and also only 4 lines sending data in this frame and address systems. That is done by the help of multiplexing technique systems. And this is also frame and address for the all 5 lines sending data. Now we will discuss about the vestigial sideband modulation technique. So what is the vestigial sideband VSB modulation technique? So we have the some drawbacks of the single sideband technique. So generation is difficult in SSB. To produce SSB signal from double sideband signals, ideal filters should be used, and selective filtering is to be used to reconstruct the original signals, and phase shift should be exactly 90 degree. In order to overcome these drawbacks, VSB or vestigial sideband modulation is used. It is a compromise between SSB and DSB double sideband suppressed carrier modulation. So in produce of SSB signal from DSB signal, ideal filters should be used. In BSB system, one sideband and a vestige of other sideband are transmitted together. The resulting signals has a bandwidth greater than the bandwidth of the modulating baseband signal, but less than the double sideband signal bandwidth. In BSB, transmission bandwidth equal to bandwidth plus V, where V is the vestigial of frequency band. So these are the different spectrum of double sideband suppressed carrier, single band, single sideband, and vestigial sidebands in this graphical representation of different spectrums. That is V for DSB and C for SSB and D for BSB spectrums in these diagrams. So there are different methods of generation of BSB. First one is the filter method. So in this filter method, there is a baseband signal, and this baseband signal is applied to the product modulator, and a carrier signal AC cos 2 pi FCT is also applied to the product modulator. And after of these two signals product, the DSB SC signal applied to the sideband shaping filters HF, and after this filter the output is the ST, that is the BSB waveform. So generates a DSB SC AM signal, pass the DSB SC AM signal through a band pass filter with the frequency response is the HF. The exact design of the filter depends on the desired spectrum of the BSB modulation wave. The BSB filter is required to have the vestigial symmetry around the carrier frequency FC. The time domain representation of the BSB wave. In time domain representation of BSB wave is the ST equal to SIT cos 2 pi FCT minus SQT sin 2 pi FCT. This is the time domain representation of the BSV waveforms or BSV signals. Here SIT is the in phase component and SQT is the quadrature component of the time domain BSV signals. The in phase component may be derived from ST by first multiplying ST by cos 2 pi FCT, that is the carrier signal, and then passing the product through the low pass filter. Similar, the quadrature phase component may be derived from SQT by multiplying ST by sin 2 pi FCT and then passing the product through a low pass filters. So in that equations, SIF equal to SF minus FC plus S into F plus FC. When F is less than or equal to omega and greater than or equal to minus omega, otherwise elsewhere equal to 0, and SQF equal to JSF minus FC minus S F plus FC if frequency less than or equal to omega or greater than or equal to minus omega, elsewhere this will be equal to 0. So the spectrum of BSB signal is SF equal to 1 by 2 AC into M F minus FC plus M into F plus FC into HF, or SIF equal to 1 upon 2 AC into M F minus 2 FC plus F into H F minus FC plus half AC into M F plus MF plus 2 FC into H F plus FC, and also SIF will be equal to 1 upon 2 AC MF into HF minus FC plus HF plus FC, and also SIF will be equal to 1 upon 2 AC MF. So SIT spectrum of BSV signal is 1 upon 2 AC MT, and also quadrature signal SQF equal to J 1 by 2 AC into MF minus 2 FC plus MF HF minus FC minus 1 by 2 AC MF plus MF plus 2 FC into HF plus FC, and also simplify this equation and we can write this signal SQT equal to 1 by 2 MT half AC or 1 by 2 AC M dash T. Thus the BSV modulated wave in the time domain is equal to 1 by 2 AC MT cos 2 pi FCT minus 1 by 2 AC M dash T sin 2 pi FCT. So this is the BSV modulated wave in time domain form. Next one is the coherent detection of the BSV signals. So in synchronous demodulation technique, here a multiplier in which BSV wave ST and carrier signal cos 2 pi FC is multiplied, and after the multiplied, the output of this product or multiplier applied to the low pass filter, and output of the low pass filter is the MDT. So SF equal to 1 by 2 M F minus FC plus M F plus FC into HF, where MF is the Fourier transform of the baseband signal. The output of the product modulator is equal to St cos 2 pi fct. Taking the Fourier transform on both sides of this equation. So this will be equal after the Fourier transform equal to 1 by 2 s into f minus fc plus s into f plus fc. So substitute for sf from first equation, we get the SCF equal to 1 by 4 mf into h f minus fc plus h f plus fc plus 1 by 4 m f minus 2 fc into h f minus fc plus m f plus 2 into h f plus fc. So spectrum of the signal S naught t at the output of the low pass filter is S naught ft equal to 1 by 4 mf into hf minus fc plus hf plus fc. For a distortion-less reproduction of the original baseband signal at the output of detector, it is necessary that the transfer function of the filter must satisfy the following condition. So hf minus fc plus h into f plus fc equal to constant. In this diagram, the representation of the magnitude response of the BSB filters, that is the between transfer function versus frequencies. Examples of BSB signal, that is the TV signals. TV signal has a nominal bandwidth of 4.5 megahertz. So this is the example of BSB signal, which is generally used in TV or television signals. If DSB modulation is used, it required 9 megahertz for each TV channels. What if BSB modulation is used? The whole TV signal is confined to about 6 megahertz frequency, and we can see these different frequency slots for use of different picture carriers and audio FM, color burst, and the remainder of lower sideband as shown in this diagram. That is the between picture carrier frequency versus frequency. And next, what is the advantage of BSB signals? So there are many advantages of BSB signals. First one is it's offer a compromise between SSB and DSB SC signals. BSB is standard for transmission of TV and similar signals. The bandwidth saving can be significant if modulating signals are of large bandwidth as it in TV and wideband data signals. For examples, with TV, the bandwidth of the modulation signal can extend up to 5.5 megahertz. With full AM, the bandwidth required is 11 megahertz. So these are the some advantage of the BSB signals. These are some reference books. First one is the analog communication by Bhatt and Rao, and second books digital communication by T.L. Singer. So these two books cover this topic. There are some multi-choice questions here. That is the very important and very interesting to clear the concept of these topics. So here we will discuss these questions one by one. First one is the power spectral density of a signal is option A even, negative and complex, option B odd, complex and positive, option C real, odd and negative, option D real, even and non-negative. So the power spectral density PSD of any signal will be real, even and non-negative. So here correct answer is the option D. Power spectral density PSD of a signal is will be real, even and non-negative. So correct answer is option D. In next question, a modulator is a device used to. So what is the modulator device? Option A, differentiate two frequencies. Option B, amplify two radio frequency signals. Option C, impress the information onto a radio frequency carrier. Option D, reduce the modulating power requirement. So here correct answer is the D, in modulator. That is a device and used for to reduce the modulating power requirement. So this is the function, or this is the working of the modulator as a device and used to reduce the modulating power requirement in the modulation technique. So this is the function of the modulator device. In next, a balanced modulator is used in the generation of which of the following signals? Option A frequency modulated signal. Option B, DSB, SC signal or double sideband suppressed carrier signals. Option C, IS, I signals. And option D, SSB, SC signals. So here the correct option and correct answer is the option B. A balanced modulator is used to generate of which of the following signal. So generally balanced modulator used to generate the double sideband suppressed carrier signal. So for the generation of double sideband suppressed carrier signal, we use the balanced modulator. We have also different type modulator. What for the DSB SC signals, we use only balanced modulators. So correct answer here is option B. Next question, what are the primary features of a transmitter. So option A, what are the primary feature of the transmitter? Option A, lower clock speed. Option B, lower transmitting power. Option C, higher clock speed. Option D, none of these. So here, correct answer is the option D, none of these, because the primary feature of the transmitter is lower clock speed, that is wrong. Second, lower transmitting power, that is also wrong. High clock speed, and this is also wrong. So none of these. So correct answer here is option D. In next, the window give a number of option A bytes, option B frames, option C both options A and B, option D none of the. So the window gives a number of both bytes and frames. So correct answer is here option C. In next, which of the given device does the data compression? So first A is the switches, option B is circuit breakers, option D is microcontroller, option D is the source encoder. So here correct option is D, because the source encoder give the data, and the function of the source encoder is to the compression of the data or signals. So here correct option is D, source encoder. Next one is space loss occurs due to a decrease in space loss occurs due to the decrease in phase shift, momentum, electric field strength, and option D is power. So space loss occur due to the decrease in electric field strength. If we decrease the electric field strength, in that case space loss occurs. So correct answer is option C here. Next one is, which of the given modulator is a indirect way of generation of FM? So option A here, inductance FET modulator, B Armstrong modulator, option C reactance 2 modulators, option D Zener diode modulator. So correct answer here is option B, Armstrong modulator, which is used to as a indirect way of generating a frequency modulation FM. So correct answer is the option B, Armstrong modulator. In next, in FM modulation, when the modulation index increase, the transmitted power, option A half, option B will be decreased, option C will be double, or option D unchanged. So option D is correct answer, because the in FM modulation, the modulation index not depend on the transmitted power. So this is unchanged. Last questions. In phase modulation, phase deviation is proportional to which of the following? in phase modulation, phase deviation or modulation index is proportional to of the following. Option A, the wavelength of the message signal. Option B, message signals. Option C, amplitude of the message signal. Option D, phase shift of the message signal. So here correct answer is option B. In phase modulation, the phase deviation is proportional to the message signal. So here correct answer is the option B. Thank you. Thank you very much.